Are robots really ready to work? Not in a lab, not in a tightly controlled test environment, but in the messy, unpredictable, often chaotic real world. Can they sweep factory floors, unload trucks, or prep meals in your kitchen while adapting to the complexities of human life? This question isn't just about technology anymore, it's about economics, labor, and the future of how we live and work. A new generation of humanoid robots is being showcased with jaw-dropping capabilities. They walk upright, lift boxes, follow commands, and even dance in perfect sync. But is this a real leap toward practical automation, or are we still watching expensive demo reels designed to impress investors? In this video, we'll take a deeper look at some of the most advanced humanoid robots on the planet: Tesla's Optimus, Figure 02, Apptronik's Apollo, Digit from Agility Robotics, and UB Tech's Walker S1, and ask the big question: are they actually ready for work? Tesla Optimus, AI that learns like we do. Let's start with Tesla. In recent months, Elon Musk has been releasing footage of Optimus, Tesla's humanoid robot, performing everyday tasks that range from basic to surprisingly intricate. We've seen it stirring a pot, sweeping up debris, and even folding laundry, each movement guided by a single neural network trained on first-person human video. But in one of the more industrially relevant demos, Optimus picked up a Model X forelink, a relatively heavy car suspension part, and placed it carefully into a metal dolly, a task currently performed by factory workers. What's important here isn't just that it moved the part, but that it did so precisely and smoothly, mirroring how a trained human would approach the task. This showcases the kind of manipulation and spatial awareness that humanoid robots have struggled with for years. Tesla's secret sauce lies in its vision-based training system, which allows Optimus to learn new skills simply by watching humans. That means, in theory, the robot can continuously expand its capabilities without needing traditional programming. Add to this its refined balance, which Tesla recently showed off with a synchronized dance routine, and you've got a humanoid that's starting to look less like a demo and more like a prototype for the factory floor or even the home. Figure 02, built for endurance on the factory floor. While Tesla focuses on domestic utility, Figure AI is aiming squarely at industrial automation. Their robot, Figure 02, has one goal: work like a machine, move like a human. And recently, it took a huge step toward that vision when Figure's CEO, Brett Adcock, announced that the robot had completed a 20-hour run on the BMW X3 production line. That's not a lab simulation, that's a production environment. For weeks leading up to it, Figure 02 was running 10-hour shifts, mimicking the endurance expected of industrial robots. This kind of performance is rare for humanoids, which typically struggle with battery life, overheating, or stability issues during long tasks. Figure 02 isn't trying to entertain or impress with human-like charm. It's built for rugged functionality, with a design that prioritizes uptime, mechanical robustness, and seamless integration into existing workflows. It's being trained to load parts, tend machines, and handle repetitive jobs that wear down human workers. If successful, it could become the missing link between flexible automation and human labor in factories. Apptronik Apollo, designed for collaboration. At first glance, Apptronik's Apollo looks like a typical humanoid, about 5'8", 165 pounds, with sleek bipedal movement. But under the hood, Apollo is a collaborative powerhouse, designed not to replace workers but to work alongside them. That makes it one of the most promising platforms for real-world deployment in logistics and warehousing. Apollo is equipped with advanced sensors, cameras, LiDAR, and tactile systems that allow it to navigate dynamic environments and respond safely to human coworkers. Its hands have multiple degrees of freedom, giving it the dexterity to handle a wide variety of objects. And thanks to AI algorithms that support perception and decision-making, Apollo isn't just following scripts. It's learning from its surroundings and improving over time. With a full 8-hour battery life, Apollo can complete long warehouse shifts, lifting boxes, sorting goods, and moving inventory with a level of awareness that sets it apart from older industrial bots. Its design prioritizes safety and scalability, which is why major companies, including partners like Texas Instruments, are investing in Apollo as a scalable solution for logistics bottlenecks. Apollo isn't just a concept, it's a practical step toward human-robot collaboration at scale. Digit by Agility Robotics, real deployment in real warehouses. Unlike most humanoid robots, Digit isn't just a prototype or a test subject, it's actually working. At the GXO-run Spanx warehouse, Digit is already carrying out logistics tasks that are typically performed by humans. It navigates stairs, walks through narrow corridors, and lifts heavy boxes, essentially doing all the things that older, wheeled robots can't. It's built to operate in human-designed spaces, meaning it doesn't need new infrastructure to start being useful. Digit represents a shift from theory to practice. It handles physically demanding jobs while allowing human workers to focus on roles that require creativity, decision-making, or customer interaction. It's not trying to replace people, it's designed to handle the most monotonous and physically exhausting work, giving teams a better balance between productivity and well-being. This real-world deployment is a milestone. It shows that bipedal robots aren't just concept art anymore, they are becoming part of everyday operations. Digit isn't perfect, but it's the clearest signal yet that humanoid robots are finally stepping off the presentation stage and into the workplace. UB Tech Walker S1, Swarm Intelligence in Chinese Factories. In China, the most ambitious humanoid robot deployment is coming from UB Tech, where squads of Walker S1 robots are working together inside a 5G-enabled Zika factory. What makes this unique isn't just the hardware, it's the collective intelligence driving it all. UB Tech has developed a system called BrainNet, a cloud-based architecture that links individual robots into a swarm. This swarm operates like a hive mind, sharing data, making decisions, and coordinating movements in real time. Each robot is powered by a multimodal AI model based on DeepSeek R1, which gives them a form of common-sense reasoning, a huge leap from traditional automation. This setup allows the robots to handle complex production tasks as a team. They are not just completing repetitive jobs, they are dynamically scheduling tasks, learning from each other, and adapting on the fly. It's the closest we've seen to a multi-robot system with real-time collaboration, and it's a glimpse into the future of intelligent manufacturing. UB Tech's approach pushes beyond the idea of one humanoid doing one job. It's about distributed intelligence and scalability, something that could fundamentally reshape how factories operate. So, are robots actually ready to work? So here's the big question: are humanoid robots truly ready to work? Despite the excitement, the answer, for now, is still mostly no. Most of what we see today are proof-of-concept demonstrations or tightly controlled deployments. The tasks are often pre-programmed or limited in complexity, and when things go wrong, there's almost always a team of engineers nearby to reset, recalibrate, or troubleshoot the problem. That doesn't mean the technology isn't impressive. It is. But it also means that these robots are not yet autonomous, not yet flexible enough to handle the unpredictable nature of real-world environments without significant human oversight. We're seeing the seeds of something revolutionary, but we're not at full harvest. These systems are still early-stage prototypes, more like ambitious students than seasoned professionals. When they are ready, a transformation is coming. But let's imagine a near future where this tech matures. When humanoid robots are finally ready to work autonomously, the transformation will be massive. Entire industries, from construction to elder care, could be reshaped. Robots could fill gaps in countries with aging populations, assist in dangerous disaster zones, or provide 24/7 service in industries plagued by labor shortages. The cost savings, productivity gains, and safety improvements could be enormous. But this isn't just about technology, it's about humanity. We'll have to ask ourselves hard questions about labor, income, retraining, and the ethical boundaries of automation. When robots can do almost anything we can, we'll need to decide what we want to do with our time and what we want them to do with theirs. The robots aren't quite ready yet, but they're getting closer with every iteration. Thanks for watching. If you've been following the rise of humanoid robotics, you know how fast things are moving, and how much is still uncertain. So here's a question for you. When robots are finally ready to take over real jobs, should we let them? Or should we draw a line to protect certain types of work? Drop your thoughts in the comments. We read every one and we want to know what you think. If you enjoyed this video, hit that like button, subscribe for more deep dives, and share it with a friend who's curious about the future of robotics.